So hey there fellow YouTubers, it's Frank Bush here again. So in today's video I plan on showing how to create a smaller size yet mobile kind of off-grid system for electrical. So I'm going to walk through each one of the components that I have here in detail and kind of talk about that as we go through the video, but I'll give you a surface level to begin with. So I've got a folding crate here that's on wheels, and I'll be putting everything into this unit. So here I have two lithium iron phosphate batteries, and within each one of these they're a 12-volt battery that has 100 ampere hours, and they have the capacity to release 100 amps and to charge at 50 amps. My plan is to use these cables here to hook these together, positive to positive, negative to negative, hook them in parallel to increase this up so that it's a 12-volt system with 200 ampere hours or 2.5 kilowatts. This unit here is an inverter. It takes DC power and converts it into AC power like you'd have coming off of the wall. So this has a 1,000 watt capacity. Like I say, I'll talk about each one of these components in further detail as I go. But this unit will end up attaching to the batteries via the cabling. I've got a fuse box here, and with that fuse box I have a negative bus bar. So when it comes to the DC appliances that I plan on hooking up to this setup, you hook up the positives to the fuses, the negatives to the bus bar, and it allows you to run DC appliances. So this unit will be attached to the batteries, and we'll wire other things into that are all 12-volt based. So we'll have the AC and the DC covered here. Then as the next step, I've got an AC to DC converter. So this is in essence a battery charger that you can plug into the wall. So I'm going to end up snipping off the gator clips that are attached on here and hardwiring it into my fuse box. But like I say, I'll show that as the video goes on. Now this has the capacity to run at 14.4 volts and 20 amperes. So that's the charge rate in which it can put power into this battery system. When it comes to this unit here, this is what they call a charge controller, and it runs at 12 or 24 volts, and this is a 20 ampere hour charger. I have other charge controllers that I'll be using. This is an Mppt charge controller, and they're the most efficient. Its job is to take the power coming off of a solar panel and step it to the exact same voltage as would be ideal to work with the battery. So the efficiency of these is really high. The efficiency of this isn't as high. This is anywhere 98-99% efficient. They're really efficient. The power coming in is the power going out, just at a different voltage and a different amperage, ideally suited, like I say. When it comes to the battery charger, the efficiency of this is a lot less, but when you're pulling off wall power, I'm not really highly worried about what the exact efficiency rate is here. Obviously you don't want terrible stuff, but this is, I believe, about 80% efficient. I haven't looked at the exact specs on that, but needless to say, it's more about being able to take power off the wall and stick it into here. So I want to ideally have it where I have DC power coming in via the solar charger, AC power coming in via the battery charger, and then I want to have DC going out through the fuse box and AC going out through the inverter. So as I move through this video, I'll show the connections and assembly of how all this stuff is going to fit into this box to make it that it's portable and mobile and that kind of stuff. So stay tuned and I'll walk through all of these things in greater detail. So like I say, I'll walk through this kind of one step at a time just to cover the entire build, yeah? So this is that folding crate I was talking about. So this is typical of stuff you'd see being used in offices where you just fold it out. It's got a floor tray in it, sits down, kind of locks into position, just little sliders on the sides, and just as simple as that, I've got a crate. It's got an adjustable handle that I can pop up to make it easier to kind of tote around. Yeah, so this is the first order business. because I want that unit to be open and set. Then I'll turn around and take one of my batteries here. I'm going to simply drop this right down and into this box and push it into the corner as far as I can set it, and kind of leave it at this point. It just stabilizes things at this point and gives me a bit of work with. So my next plan is to take the inverter and strap it in here. So the thinking really is I'm going to have the battery here, I'll have this other battery sitting in here, I'm going to have the inverter here, and I'm going to have the battery charger sitting about here. And then I'm going to hook on the solar charge controller out on this side or on this side. I haven't decided yet exactly how I'm going to hook this on, like what location for the solar charge controller, but probably on the side here. We'll see. We'll just see as the build goes. So let me just grab the inverter and we'll kind of set that in as the next step. Yeah. So for the next step, I'm going to take my inverter that I have. I'm going to roughly figure out where I want this thing to go. Now I could snip these cables and make them as short as possible and everything else, but I want to keep this build as simple as possible, and potentially I'm going to use these components again in the future. But my thinking really is this inverter sits kind of perfectly into this space. So in order to secure this inverter, my plan is to turn around and I'll just grab my drill, take a drill a couple holes into the sides here through this unit, and then I've got a bunch of zap straps that I'll daisy chain together to kind of strap and secure this inverter to this position. So I'll just do that now. Like I say, nothing really complex here. It's really just to make sure that this inverter is not going anywhere as we go through time. I think I gotta come at it from the other side for this one. Maybe about there. Okay. So I've got my holes popped. And all I'm really gonna do is just feed these zap straps through these little holes that I just drilled. I don't mind having these holes in here when it comes to kind of how this build moves forward, because all these holes are going to do is add airflow. So as I'm kind of binding this up, I'll just make mention about these LIFEPO batteries. So they're different than sealed lead acid batteries. When it comes to any type of battery for using for solar systems like this, you know, you can look at the AGMs and the sealed lead acids and all that kind of stuff. From my lens, all that stuff is really just garbage, to be quite honest. Of the LIFEPO batteries, they're expensive. They're, you know, close to about $800–900 a piece, so they are pricey. But when it comes to usable power that comes out of them, you know, when they say 100 ampere hours, you can use 100% of that. And you can do that for up to 4,000 cycles. So if you're using these on a daily basis, that brings you out to, you know, roughly 10.5 years worth of daily use that these units can endure before they come down to 80% capacity, which is still an amazingly high amount of usable power in those units. Whereas sealed lead acids, you know, if you discharge them down to say about 50% or so, potentially you're going to be doing damage to the battery and it's not going to last as long. And if you're lucky at best with a well-maintained sealed lead acid battery, you're lucky if you get, you know, 8 years tops. Normally you get anywhere from 3 to 5 years. Whereas these LIFEPO batteries, they can get up to 10–20,000 life cycles if treated properly. You know, there's a significant difference with it. With sealed lead acid batteries, they normally like to be, you know, 100% charged, and the more you discharge them, the harder it is on the batteries. With lithium iron phosphate batteries, their ideal their ideal kind of storage, the amount of power that they have in them, sits around 50%. So if you use these batteries, I've got all the basic straps on for the first part, so I'm gonna have to grab my pliers and stuff to tighten it down, but sorry. But when it comes to these, you know, in 10 years from now, they'll still have 80% of their capacity that's usable power. You know, whereas a sealed lead acid battery in 10 years from now, it's done. You know, it's literally a lead weight just sitting in your, you know, environment. Whereas these lithium iron phosphate batteries, they really can last a long time. If you're cycling anywhere from say 75, 80% full down to about 25% full, you can get up to 10, 15,000 life cycles out of this. I'll be dead by the time that this thing is fully pooched. And because I'm going with the larger capacity, it's going to make it that there's a lot of usable power in this that'll still be available in, you know, 10, 15, 20 years down the road. It might not be the same amount that it is now, but it'll definitely be there and available for me. So by building this system out with the capacity I have, it was really just to make it that I know this thing will last for me for the long haul. And that was the ideal reasoning behind purchasing these batteries. I didn't want to have to keep buying batteries over the years over and over and over again. You know, that just puts maintenance on my wallet, if you will, or, you know, makes it that I have to maintain it through time economically just to keep it going. And I don't want that. I want this unit to be just built and something that lasts through time. If I have to replace anything, it'll probably be the charge controller that plugs into the wall. I find they tend to be the first things to go. But even with this build, I don't plan on using it, you know, wall power is my primary power supply. So I've loosely attached these zap straps. There's some tag ends I'm going to have to go and clip off, and I'm just going to tighten them down. So I'll do that off camera, and I'll come back with this kind of fully bound on, yeah? So and then, like I say, these little tags, I'm just snipping off the last ones. So this AC inverter is now strapped in here. Now there's two types of, well, there's lots of different types of inverters, but there's two kind of main bodies of inverters. There's the pure sine wave and the modified sine wave. I recommend to anybody to go with the modified sine wave, or sorry, the pure sine wave inverters. They produce cleaner electrical output when it comes to sensitive devices. So the amount of power that you can pull off these is normally what they're rated at as the kind of main number that they tag on this. So this can pull 1,000 watts. I could easily step this up to a 1,500 watt or 2,000, 3,000 watt, that kind of thing. It'd end up taking up more space. For this build out, I thought 1,000 watts would give me power to power pretty well everything that I wanted this unit to demand, if you will. So, but as you can see, I didn't clip the cables or anything off of it. I purely just let them sit. And now I'm going to push this cable for the negative because of how I want to do this kind of wiring. I'll just feed this out for now, so there's not a ton of stress, but I really want to make sure that this negative cable is flush against the side as much as possible. I don't want to peg it down because I want to make all this stuff really easy to remove. But what I will do is take my other battery now and slide this down and in where, in fact, let's see if I can drop the cable in after the fact, just so that the battery sits nice and flat. I know I'm not being the most articulate in this video, but it is what it is. So I just moved the cable for the negative out of the way first. I'll take my battery, set it down in so it's nice and flush up to the side. Now this is going to be positive to positive, negative to negative. That's the way I'm going to wire that up. And I've got these wires here that'll end up doing that. So I'll have this cable that connects the negatives, and I'll have this cable that connects the positives. But for the negative coming off the inverter, I want to, because it is longer, and I don't like snipping cables if I can avoid it, I'm going to end up feeding this along the outside of the batteries to kind of keep that wire so it's out of the way, and it's going to connect to this negative connection right here. So just kind of set it down where it's secured enough that it's out of the way, and I can still reach that terminal with ease. So that'll kind of deal with the negative and where I want to place that. And then the positive, because the positive had the extra cabling, I'm just going to set that to the floor as much as possible, and the positive is going to connect on to here. So I've got lots of room. The cables aren't really going to be in the way. This cable is going to end up hooking on here. I want to create an open area on the face of these batteries where the fuse box is going to go. And then, like I say, I'll grab my glasses here and read you the exact specs. Because I'm getting old, I got to put on reading glasses. I'll read you the exact specs on these LIFEPO batteries. So the rated voltage is 12.8 volts. The rated capacity is 100 ampere hour. The rated energy is 1,280 watt hours. The maximum charge current is 50 amps, and the maximum discharge current is 100 amps. The operating temperature is -20 Celsius to 50 degrees Celsius. Now they say that on these batteries. So when I connect these in parallel, the numbers I just stated will all double. So the maximum charge current will jump up to 100 amps. Not that I plan on throwing that much power into it at one time, but the maximum discharge current will be up to 200 amps, and that's all based at the 12.8 volt. Because I've hooked them in parallel, those numbers will double. Now, like I say, when it comes to these operating temperatures, you know, that's all about the discharging of the power from the battery. When it comes to charging these batteries up, the only limitation to these lithium iron phosphate specific, you can get ones that have heated elements on the inside so they can work to lower temperatures, but they don't like to charge 0 degrees Celsius or below, so 30 degrees Fahrenheit or below. If you charge these batteries when they're down below, you know, freezing, if you will, you can do damage to the batteries, which will shorten the life of them. So be mindful of that. And if you live in colder climates where it's going to go below freezing on a regular basis, there is kind of cold weather versions of these batteries. They cost a little bit more because they have heating units and that built right into the batteries themselves to help warm up the battery and get it above a freezing inside the battery, where it'll use its own power to do it. So it'll, you know, affect a bit of the capacity that you can pull out of the batteries, but it'll warm them up and allow you to charge them below 0. So, you know, if you are in cold environments that go below 0, you know, freezing on a regular basis, below 32, then you would want to consider using the ones that are the cold weather version of this. But the next step, so I'm pretty well ready to go with the inverter and with the battery. I'm going to end up putting a spacer in here later on just to ensure that as this cart, you know, jostles around for movement, it won't make direct contact with this inverter. I really want this inverter to not have anything else touch it, but I want it to have good airflow around it, and which it does. There's lots of air that can move in around this unit, because when it's converting the battery power to AC power and it's putting out this 1000 watts, fans will kick on the inside of this to kind of blow the heat off that it's generating from that conversion. So you don't want to have anything really touching your inverter, and you want to have it that there's airflow around it. You don't want it packed in too tight. You want to make sure that the heat has a way to escape from those fans. So the next step in this, I could turn around and hook these on right now. Just connect the negative and the positive and connect these wires up, and I could actively be using this inverter right at this point in time. But my next step will be to take my fuse block, and I've got double-sided tape. I'm going to tape my fuse block onto here. So let me shift angles of the camera, grab the fuse block and that kind of thing, and I'll take that to the next scene. Yeah. So like I said, the next step, I'm just going to grab my DC fuse blocks that I have here, fuse box with the negative bus bar, and I'm just going to turn around, and on the back side of that, I've got mounting tape. You can pick this up at the hardware store. It's like a two-sided tape that's really strong and sticky, if you will. So I'll just grab that. I'm going to put a couple strips of this. I'll just use this. Should have grabbed the scissors really, but such is the nature of life. Just stick that onto there. Take another strip. Stick that onto there. Now when it comes to this negative bus bar, or in the fuse box, the positioning of where I want this to go is kind of important, because there's going to be a lot of wires coming in and out of these fuses. Let me just pop that off again. Of course I put the lock on by accident. There we go. Just set it to the side. So there's a positive input and a negative input. All the negatives are going to be on this side, and all the positives are going to be over on this side. Now I've already set in a varying range of fuses I'm going to use in this fuse block, because I know the kind of devices I'm going to be attaching, but I'll go through that in detail later. So my thinking really is, when I mount this, I'm just going to stick this negative out of the way for a second. So when I mount this, I'm going to want to mount this kind of centrally located on these battery stacks, so I have room to connect my wires and have them flow out off of these different connectors. So, but at the same point in time, these batteries, and I'll talk about it later in the video, they have communication ports where I'll connect up my monitor that'll tell me what the state of my batteries are in charge. So I do want to make a little bit of room for them as well. So I'll just kind of back this up a little bit. And that location there looks like it'll be pretty well ideally suited. There's lots of room for wires to flow and that type of thing. So knowing that, I'll take my two-sided mounting tape that I have and just peel off the protective sticker. Now this stuff holds on there pretty good, so you know, when you decide where you're going to stick this, spend lots of time thinking about where you're going to put it before you go putting it, because depending on the tape, it can be difficult to get off. So I'm going to stick mine right about there. And now that fuse block is on there. It's not really going anywhere. So the thinking now really is the main connections that are going to be going to these batteries, I'm going to have my positive and negative connecting onto these two terminals for the inverter, and I'm going to have from the negative running to the negative and the positive to the positive, I'm going to hook on 10 gauge wires that connect to these terminals. That'll then give me the ability to output the AC and output the DC from this battery. So let me grab my wires, and I might have to do a bit of crimping and cutting to create the wires to the right steps, but I'll put that into the video as well. But we're making good headway. Okay, so I've got some 10 gauge wire that I'm going to be using to connect the positive to the positive on the fuse box, and I've got black 10 gauge for the negative to go from the negative bus bar off to the negative terminal. So first order of business, I'll just stick my wire into my stripper, clear off a little bit of the terminal. I'll get that in a minute. Now when it comes to connecting to the terminals of this battery and the terminals of the fuse box. So the terminals of the battery, I'm using a larger ring terminal, and then I've got a smaller one to connect to the fuse box. Hopefully the camera caught that all right. And really, they're more suited for the sizings to connect cleanly to those two locations. So I'll do the positive first, where, like I say, I just stripped the wire. In fact, I'll probably take a little bit more off that wire. I don't mind having a little bit more of the copper. Come on. Just doesn't want to strip it. There we go. So take a bit more of the copper off, or the protective sheet off. And now I'm just going to take this terminal, slide it onto there where I can see a bit of the copper is sticking out on the end. Now I'll take my crimping tool. There's this is a number 10 yellow. There's a yellow on the crimping tool. So turn around and slide that in. And want to really crank down on that and make sure it's got a good connection. Still a bit of wiggle, so. Now, on the plastic part back a bit from where I just crushed the terminal connection, I'll just come back a little bit and squish the plastic as well, because there's no harm in it. I really want to make sure that this thing's on good and solid. You don't want these things slipping off. So, give it a good tug on the wire. Doesn't seem to be going anywhere. Nice solid connection. I'm okay with that. So the thinking really now is this is going to go, like I say, from this positive to the fuse box. So I'm going to figure out what the length is that I need that wire. It's going to be roughly about there. I give it a little bit extra just so there's some wiggle room, because I don't mind having that in the system. So I'll snip it about there. Double check my measurements, because always good to do that. Yeah, it gives me a bit of extra room. So then I'm just going to snip it right at that point. And then I'm going to strip this end of the wire just the same. Really got to get new wire strippers. I'm not the biggest fan of these. But as you can see, cleared off the protective sheath off the wire. Now I'm going to take the smaller terminal, which is more suited to the ring terminals, that's more suited to the fuse box. So I'll slide this on. Now I know that I'm going to be going flat to flat as such. So I want the two terminals to be connected kind of on the same plane. I don't want it to be 90 degrees as such, because it's going to cause me to have to put additional twists in the wire. So I'll make sure that it's facing that way. Hopefully that makes sense, but I'll end up making it that way to connect on that ring terminal. Slide it into the crimper. Make sure that I'm in good and solid. I give it a good squeeze. I really need to get better wire crimpers. So, and then I want to give that a good tug, make sure that terminal is really connected to that wire solid. They both appear to be a good solid connection. So now the thinking really will be, this will just connect on to both those terminals as such. So I can start to wire that up at this point now, where I know that let's just little screws and bolts that old eyes always have problems. Let's put that there. So the thinking really is I'll hook on this to the fuse block to begin with, and then I'll put on, oh, I should have put one more on. Hold on, let's put that on. Or did I already have one? Yeah, I already had one there. And I'm just screwing around with the washers and stuff. So put that on, put on my washer, put on my slip ring, and put on the bolt. I'll end up tightening this down in a minute. And when it comes to this positive terminal, so now I'm just going to feed my bolt through both of these and connect it to the positive. So the positive side's connected. And now, like I said, the inverter is going to connect onto this terminal. So I might as well just hook that up now. So through my inverter, through the connector cabling. And if I remember correctly, this was 4-gauge cable, just for bearing's sake. I picked this up at the hardware store for, I don't know, they were like $7, $8 a piece. They weren't expensive. I don't like doing larger scale crimping of wires. I'd rather just buy them store-bought if I can get away with it. I mean, I'll do it if I have to, but I always find store-bought ones are, you know, finished nicely and everything else. And if you get them to the length you want, they're normally dirt cheap. So, like I say, there's some tightening up that'll be involved here. But this is really the wiring on the positive side that'll occur. So I'll do the exact same thing on the negative side, and then I'll just cut back when I have all those terminals connected, yeah? So I just did the same thing with the black wire, where I've got the large terminal for the battery and the smaller one to connect to the negative bus bar. So do the exact same on this side, where feed through that connector, through there, just connect that on. And do the exact same for the negative bus bar. Okay, so let's put that on there. That's going to connect as such. Put that on. Slip ring. So that pretty well connects up the negative bus bar to the negative. Now with the negative from the inverter that ran around and the connector that makes the batteries work in parallel. Connect those all in place to the terminal. It's being finicky. Come on. In fact, I'm going to put that negative around the outside. I really want the wires tucked off and away from this fuse block as much as possible. I'll end up probably even strapping them down to ensure that they stay at a distance and away. So, in fact, I might as well just do that now. One of the joys of working with these crates, it's like, yeah, pop a hole right there, and we're going to do the same a little lower. There we go. Grab one of my zip ties. Maybe I can do this one. Slide that. Come on. Slide that in through there. Out through there. It pulls everything tight off to the side. Strap that down. Okay, so I just did it off camera, but I tightened up all the bolts so that everything's kind of set in place. Now, I'm just gonna brace that positive wire over on this side. Just so everything's kind of locked down and stable. Stuff isn't jiggling around too much as we move through time. So let's put that through there. Come out through here, back in. And like I say, I don't mind those little air holes being in there. They're just going to allow air to move around the unit. And when it comes to a lot of these electronics, they tend to generate heat. So it's not a bad thing to have airflow. Now I see these guys out there and they build them all in these closed-in units and everything else. These electronics want to breathe, if you will. They've got fans built into them to cool down. Now, the more you pack this stuff in to try to save on space, yeah, I understand you want to have an efficient space design, but the more you pack this stuff in, the more the heat increases and the higher the chances that you're going to have issues with your performance as you move through time. So, either way, the positive strap down, the negative strap down on the opposite side there. I'll just give that a little bit of a tug to make sure it's nice and tight on the zap strap. Ah, there we go. Now this positive's good and out of the way. Now as you can see, as I was talking about earlier, on this fuse block, it now opens it up where I can have wire flow. And all the negatives to one side, all the positives to the other. There will be I know people make comment probably about, oh, this positive wire is sitting close to here. I will put a piece of insulative foam that sits into here. Not enough to stop the airflow, but enough to just make sure that those don't make contact. And potentially I could even zap strap this wire so that it was forced. I'll just do that now. There's no sense in taking risks, right? Let's pop a little hole here. And another one right beside it. There's an ounce of prevention at this point in time, right? So I'll just feed that through. Let's see. Feed that through here. Hook around that positive cable. And just to ensure that that positive cable never makes contact with the inverter. And by setting these zap straps in here, it's just applying tension where this cable just doesn't have the ability to reach across. So I'm okay with that. I'll still put the foam in either way because I like erring on the side of safety. I don't want to damage my own equipment. But there you have it. So I now have it where I've got AC power here, and we'll hook up some devices to this in a bit to confirm that the DC is flowing, but the basic connections of your battery to your fuse block and your inverter are established now. The next step in this process will be to take this battery charger that plugs into the wall. Like I say, I'm going to snip off these gator clips on the end. I'll keep a bit of cable on them because I have use for those types of things. But my thinking really is this is going to now sit down into this location, and it'll be zap strapped to the box as well. And then make sure I have distance from the inverter and stuff so that there's airflow between both units. And then this cable, the positive and the wire that come off here, are going to connect to the positive here and the negative bus bar here. And that'll allow me to then be able to charge this unit off the wall, where it'll flow through. These fuses will be here to protect things. And really all the devices that you hook on in the DC now, with this inverter, there's circuit breakers and those types of things built into it. So if there was a huge flush of current, and the battery has it as well, if there was a huge flush of current that rushed through the system, it could potentially damage these units. But because they have circuit breaker technologies and those types of things built into both the battery and the inverter, I'm not overly worried about putting a fuse on this positive line connecting to the battery. If these were sealed lead acids, 100%, I would want to have a fuse right here that this inverter connected to before it connected to the battery. And normally they'd be rated at about 1.25 of whatever the amperage is that you're drawing. So, you know, if you're drawing 100 amps off of your inverter, say, you'd want your fuse, your inline block fuse, you'd want that to be at, say, 125, where it's a step above what the capacity is, but it'll stop any excessive amperage that would flow and damage your units. So, needless to say, I'll stop here and snip off these gator clips and do the same kind of terminal connections like I showed earlier in the video on the ends here and here, and that way I can connect those up to the DC block. So I actually don't even think I need to use the ring terminals. I got to use the other ones, a spade terminal, I think. So I got a bag of wires and plugs and stuff. So needless to say, I'll clean this up a bit. I won't bother putting that into the video, but I'll just show when it actually gets wired into here. And I'll show the connecting the battery charger onto the box and kind of stabilizing it and bolting it in, yeah? Okay, so I snipped off the alligator clips that were on there and threw on some number 10 spade terminals, so that I can connect cleanly to the fuse box. So the first order of business I want to do, take some more of my trusty zap straps, and I drilled a couple holes. I didn't bother recording that, but I drilled a couple holes here just so I have a place that I can strap the battery charger to. So I'll just start to feed all that in now. I won't that go on. Come on now. Kind of set these up to go. So it's early in the morning, my kids are getting up and moving around, so you might hear some noise in the background. These things happen. So, but the thinking really is I'm going to have the AC cable sticking out the top, and the battery charger is going to come down and in as such. I'll feed that out through the hole in the bottom. And wrap it around. See if I can actually get it to click into there. I got one click. That's always a good sign. And then this one I'll feed through. It's just kind of loose for right now. Start to really tighten that up now. Yeah, I like that position. So now I'll just take my pliers and make sure that's on there nice and tight. Just so it's not going anywhere. I want these to be really secured. I don't want them moving around at all. There, that's locked on there pretty tight. It's not going anywhere. Now these two spade terminals, I'm just gonna tuck them underneath and feed them up through, just to keep the wires, like I say, really keep the wires tight and out of the way. And I'll probably connect it onto right here and just zap strap that in. So I'll just grab my drill and do that now. There we go. Nothing overly complicated. I just really want to make sure all my cabling's kind of pinned down and secured, that it's not going anywhere. Because when this thing's out in the field, I'm going to be bumping it around, pulling it in and out of my truck and all that kind of stuff. Just want to make sure everything's kind of locked down and stable in every way. And then I'll come back and snip off all these little tags as we go. But so now I've got a positive and negative, and as reference from the gator clips that I snubbed off, the red is the positive, the blue is the negative. So when it comes to the bus bar now, that's going to take the blue one, and the fuse is going to take the red. So I've got a 25 ampere fuse here. I'm just going to pop that out so I'm not connected to that at all. At this point, I'll loosen it up. And it'll be the same with the negative. Loosen that up. And I'm simply just going to take my connections, hook them on there, and tighten them down. So the negative's connected. Like I say, there's no fuse in here, so I'm not going to make a full connection either way. But I'll feed that in. Now you can see it lit up to show that there's an issue with the continuity to the circuit. It does that to let you know that either a fuse is blown or the connections aren't fully established. Make sure everything's nice and tight. Obviously I don't want to strip bolts or anything, but make sure all my stuff is locked on nice and tight. Okay. All seems pretty secure. I'm happy with that. Like I say, all the wires are kind of away from each other and out of the way. I'm now going to take that 25 amp fuse, and because this is a 20 amp battery charger, I'm stepping up the 1.25 that I was talking about earlier, and then I'm just going to plug that in to the fuse block, and now I'm connected. So I've got my AC out and my AC in all wired up. So now as the next test, we'll plug this into the wall, make sure that we're taking a charge, and we'll turn on the inverter and put a load on it and make sure that the charge is going out. So the next step is kind of the fun step. We'll get to see if things explode at this point in time or not. So I've got my plug to the battery charger. I'm just going to plug that into some wall power, and the fan's kicking in. So I'm throwing a charge into the battery right now as we speak. I'll grab a monitor. Hold on. I wasn't going to hook this on until later in the video, but I'll just grab my monitor and plug it in. I'll show this in detail. I'll pop it back off after I show you, and I'll show you this in detail. So, like I say, the AC charger off the wall is throwing a charge in right now. I need to hook on my other cable to detect it properly. Bear with me. So the communication has to go to the first connector on the secondary battery and the secondary connector on the primary battery. I've connected that in. Take my monitor, throw that on. And it's lighting up now. It'll take a second for it to detect the batteries and all that happiness. So it sees that I have two batteries now. They're sitting at a 13.2 volts. They're 60% full pretty well. And there's 20 ampere hours going in. Or sorry, that's 200 ampere hours battery capacity. And I've got 17.9 amps going in off of the wall power right now. So hopefully the camera caught that okay. So I know that to plug into the wall, I can simply just plug it in and I'm going to catch pretty well about 18 amps. So this is rated at 20 amp, but you always get a bit of losses and stuff. So I've got 18 amps at 12.8 volts going into these batteries at this point in time, if you will. Now at the same point in time as I'm charging off the wall, I can also be running loads. So for classic testing purposes for people that play with solar stuff. So I'll kick on my inverter. As you can see, my inverter can run at the same time as I'm charging these batteries. I can be pulling power from them. So I've got my hair dryer and I've got a little 400 watt ceramic heater. So I'll plug those both in. And this is really a stress test on this inverter. This inverter is rated for 1000 watts, but the combination of these two devices pulls about 1200 watts. So I'm pulling more than what this inverter is rated for. Now I've already done some stress testing to see if this works and how well it works. So like I said, I've got 18 amps going in. I can turn them on, and so I've got both the ceramic heater, hopefully you see the red light, and the hair dryer going at the same time. It's pulling 1.2 kilowatts from the batteries. And what I'll do is I'll just shut down my charger that's coming off the wall. I'll just kill the power to that to show you how much power I'm drawing. So at this point in time, hopefully the camera's catching this. At this point in time, I'm drawing 99.3 amps, 97. You know, it'll bounce in around that range. I'm pulling that much off these batteries at one time. And like I say, because I've got these two batteries, here, I'll just kill that. That can run for about 10-15 minutes before the inverter overheats and it wants to trip. So I'm not going to bother doing that. I've already stress tested this previously, but just to show you that I was pulling, 1200 watts worth of power through this inverter. I can do that for about 15 minutes before it'll pop because it's taking too much power. And normally you wouldn't want to run maximum of what the inverter provide. If you know you're wanting to run larger loads, then it's best to switch up to a beefier inverter. So I'll just simply turn my battery charger back on from the wall again. So like I say, 17.9. Now if I quickly just plug all this stuff back in, I shouldn't have taken it out so quick, but if I quickly just plug all this back in, what you'll find too, and I'll turn them both on. Oh, help if I turn the inverter on, right? So I'll turn both these units back on, and you can see now the 18 amps that I was taking off the wall is now offsetting the amount of amps that I'm taking off of the battery. So even though I'm running the same 1200 watt load, I'm only pulling 75, 76 amps off the battery, because the wall battery charger will throw to these devices first and make it that I'm not hitting the battery as hard. I know the light wants to kind of auto kick off, but you can see 74, 75 amps that it'll pull. So it still would drain this battery because, you know, I'm pulling a heavy load here. But having it plugged into the wall helps offset that and would buy me a longer time, if you will, before these batteries would run fully out. So I can run the equivalent of this much power. I can run for, you know, 1,000 watts for about 2.5 hours before I'm going to run out of power. And you can see it jumps back up to the 17.3, and it'll bounce around depending on the resistance it comes across within the battery stack and that. But I'm able to charge the battery at the same point. I'm able to pull energy from the battery, which is good. You know, I want to have it that power can flow in and out of this device seamlessly. So I'll just turn this off, but that's tests now that yes, the AC coming in and the AC going out is all working as expected. Like I say, I wasn't planning on showing this battery monitor stuff until near the end of this video, but I just had to hook it on so I could show you guys, you know, without just telling you. I could show you by the meters of kind of what the power flow was that's happening here. So I'm just going to pop off my meter though at this point, because there's still some stuff to be done, if you will, for this setup. But it gives you an example now of, I could use this without even being any type of solar panels being used in any way, shape, or form. This would still be a very effective electrical generator. I could wheel this out into the field. I'm stuck and limited to, oh, I just unplugged it and stopped charging. I'd be stuck to roughly 250 watts worth of power that this inverter generates going into my batteries, which is, for what's going on here for this construct, is relatively slow. So I might as well just leave that charging for a few. And as you can see, it's just that simple. Plug and unplug and no problem. But I could use this where I could power AC devices, no solar involved. As long as I knew I was going to have grid, I'm storing 2.5 kilowatts. I could stop at this point in time and have an effective system that wasn't relying on any type of solar. The next step up would be attaching the solar component though. So the thinking behind it is, there's 2 ports for the power to come from the solar panels into this box, and there's 2 ports for the power to come out, and I'll plug that into this fuse box as well, because it's all DC power. So just like I did with the battery charger feeding in through the negative bus bar in the fuse box, the same kind of thing is what's going to happen with this solar charge controller. And I'll end up putting Mc4 connectors onto the solar panel input, and that way I can attach and detach solar panels whenever I want to use them. So I've got to stop for a second and kind of think about where I want to strap this on. Because of the size of this, I'm no longer going to be in the box. I'm now going to have it strapped to the outside of the box. And I'm okay with that, because potentially I could have multiple charge controllers connecting to multiple solar panels that were all feeding through and into this fuse box as I went through time. I could have a solar charge controller here, a charge controller here, a charge controller sit on this side. I probably wouldn't on this side, but it gives me the capacity where if I wanted to hook on multiple charge controllers, I could do it with ease. And yes, it's going to be to the outside of the box, but like I say, I'm okay with that. To me, as long as it's strapped on and it's secured and everything, and the wires aren't, you know, dangling out too much. But at this point in time, it's got a real lean setup. And I've got these two holes where I secured the positive lead terminal. I could easily feed the wires in through this hole, or in through these holes, from the solar charge controller, and have it be a very compact setup where there isn't a lot of dangling wires on the outside and that. And if I do it opposite to where these handles are, I don't have to worry about it having problems too much as we move forward. I do plan on hooking on a couple of other devices to this zone though, so I'll cut to that as the next scene. Yeah, I'll look at doing the solar charge controller as the next step to help complete this solar generator or electric generator build, if you will. Okay, so I decided to mount the Mppt charge controller to this side. Potentially I'll have another one matching on this side at a later date. But I'm just drilled a couple holes and stuff. Now I'm just zap strapping it down. So nothing really complicated or worth seeing. So just make sure it's braced on there nice and solid. Alright, so that charge controller is on there now. It's definitely not going anywhere. I'll just snip some of the spare wire, or sorry, some of the spare zap strap so it stays nice and clean when it comes to things. I'll throw some of my wire debris over there. So now, hopefully the camera's catching this. Now, because there's a whole space here, I should be able to feed the wires in right here and then into my fuse box. So, and like I say, that's on there good and secure. So I've got to cut some more cables as I did earlier. But when it comes to connecting to the charge controller, I'll see if I can get the camera on a better angle here of wiring into this unit and then into the fuse box and stuff. So let me cut angles and that kind of thing, and then I'll see if I can get a better angle. But either way, the solar charge controller is attached to the unit fairly securely at this point in time. Okay, so now for this solar charge controller, I've got these two. This is the solar positive and negative, and this is the battery positive and negative. So I'm going to take some more of my 10 gauge wire, and that is going to end up feeding directly into the battery positive, and then the black 10 gauge wire that I have is going to feed into the battery negative. So I'm just going to strip some wires. Now I don't need any terminal leads on this end. I can simply strip these wires. Got a piece of the old one stuck in there. Just 2 seconds. I really could use some better wire strippers. So simply just set it into my wire stripper. It strips off some of the protective plastic. Now I need my screwdriver, which is right there. So I'm going to turn around and just make sure that's a little clean. Now, like I say, the battery positive I'm going to set into there and push it in nice and deep into that unit and simply just tighten it down. Hopefully the camera's picking this up half decent. So I don't really want to strip it or anything. So that cable's in there nice and solid. Like I say, I've run it to the inside of the box. So the amount of wire exposure is going to be minimal on the outside of the box. And it's right in an area where there is some corners to kind of protect it. I just want to make sure that I've got enough cable to run it to the fuse box. Just like I showed earlier in the video. I'll grab my wire snippers. And I'm going to end up... I really need new ones of these too. Oh well, such is life. And I'll end up putting a spade terminal on there just the same as I did. So for connecting to the fuse box, so I've got these number 10 spades. I'll just strip this now. Make sure it's set in nice and deep. Say, I'm not the biggest fan of this wire stripper. There we go. So now I've stripped that. I'll put on my spade terminal connector. I use the yellow spot on the crimping tool. Set that on. And just crank down on it. Make sure it's really on there. That seems pretty solid. Now I'll kind of squeeze the plastic as well, just because I got a habit of liking to do that. And I'll double crimp that just to make sure, because like I say, this crimping tool isn't the best. So that's my positive. That'll end up feeding into the fuse box. I'll do the exact same thing with the negative. So, and as you can see, I've connected the positive to the positive terminal and the negative to the negative terminal. And I'm just feeding them in through this little opening over here. And just to secure them down so they don't get jolted out in any way, I'll feed another zip tie, zap strap, whatever you want to call it. Feed another one of those onto here. And I've got plenty of room to run this in now down to the fuse box. And I'll just make sure I'm not applying too much tension on those. But that's the thinking, really. They're secured on there pretty tight. I'll just snip that. All right, so now my wires are feeding in. I'll switch the camera angles and link this up to the fuse box now. So now you can see those two wires coming in. I'm going to do just the same as I did with the battery charger that connected to the wall. I'm going to turn around and say, okay, I don't want that fuse there. That's a small fuse. I want to use another 25 amp fuse, and I'm just going to set that to the side for a second because I don't want this circuit active while I'm doing the wiring and stuff. I'll plug in the fuse into it as the last step to activate the circuit. So I'm just going to simply do like I did before, loosen up the terminal here, loosen up the negative, and take my spade connectors that I have now. I'm going to connect to the positive first this time. I don't find it really makes much of a difference when you don't have the fuse set in, but either way, screw that down nice and tight. That secures the positive to the fuse box. It's on there good and solid. Probably strap that again here just to make it really out of the way. I'll do the exact same thing on the negative now. Take the negative, I want to get in underneath that washer. in underneath the washer now. And I'll screw that down nice and tight. Okay, so that's all locked in place now pretty good. And that should, as soon as I plug in, now because this was 20 amp, I'm using a 25 amp fuse, the 1.25 as a step up, if you will. As soon as I plug this in, my solar charge controller, excellent, it's lit up now. I'll switch angles and show you that. But first order business, I want to secure these wires so that they're out of the way again. So I'll just grab my drill, plug it back in for a second. Figure out roughly where I'm setting this. It's going to be right there. Just a place to feed another zap strap through. Grab my zap strap through the one hole, around the wires, back out the other. Oh. Feed it onto itself. Make sure that's all nice and set. Yeah, I like that. They all seem secure. There we go. Grab my snippers, get rid of the rest of the tie off. All right. So now my solar charge controller is hooked in to the system now. Okay, so the next step when it comes to wiring up for the solar charge controller is going to be creating some Mc4 connections. So I know that the positive leads coming off my solar panels come out to the male. So I'm going to want to go with a female connector on the positive, and then the inverse is true. So for the female connector, there's two metal inserts. The male goes into the female, and we're going to use the male with the female plastic piece here. So the first order of business I'll do is set the wiring. Let's see. Set the wiring so that it firmly goes inside. Hold on. Firmly goes inside the male connection. And I want to get it to the point where it's up flush to where the wire protection is covering. And I'm just gonna, I don't really want to use these crimpers. Yeah, I'm into it now. So I'll take my crimper. I've got a yellow crimp here. So I'm going to take my crimper, slide it on. Sorry, these are really old crimping tools. And crimp this on to that connection. Now I've only just lightly done it at this point in time, but I'll want to set that on nice and firm. I want to make sure that that little male connection is on solid, and it is. It's not going anywhere. So now I'm going to take the female part. I'm just going to unscrew this, slide this onto my wire as such, and then I'm going to feed this through, and it'll stick out through there. And as I feed this through, I'll hear it kind of click, and then it wants to lock. So now it's kind of on there snug. I'm just going to take this piece, wind it up, make sure that's all nice and tight. There is little tools you can use to tighten these up, but I feel like I got good enough hand grip strength to do that. And as you can see, the metal on the inside there, I'll do the same now with the negative. So on the negative, it's got a female connector that will go inside the negative Mc4 connection. Now these Mc4 connectors, they're pretty standard when it comes to solar panel stuff. So on my solar panels, I use Mc4 connectors to connect to my solar panels. So just the same, I feed it on all the way up to the point where the insulative plastic starts. I like to pinch it on lightly and then turn it and kind of crimp it down that way. Make sure it's as tight as it'll go. I want to check my crimp now. Yeah, it seems to be on there nice and solid. Do the exact same thing with the male connector. And just unscrew this part. Slide that onto the end. And normally you would slide this part on prior if you already had an Mc4 connection on this end. But I'll take my male end of the Mc4, slide it on. You hear that click. Hopefully the camera picked that up. Kind of locks it in place. Now I'll just tighten this part on. And there you have it. I've got my Mc4 connections now that I can hook onto my solar charge controller, which will feed in through the solar positive and negative that are on the charge controller. And I'll just be able to clip in, they clip in just as such, my solar panels. So I can pop them off and clip them on as I choose to use them, yeah? So I'll switch angles here and I'll just bind this into the solar charge controller, and that way all the wiring's done for that, yeah? Okay, so now the next step, like I say, I've got these ports that I can feed in on for the solar panel. So I've got my red, which I'm using as my positive. I'm just going to put that into the PV plus, the photovoltaic plus, if you will. And in fact, I'm just going to feed this through here for now, just to help it leverage that. Just keep it out of my way and stuff. So I'll simply set that in, make sure it's in there all the way, and then just tighten down this unit until it secures the positive. So the positive is good and secured on there. Do the same thing with the negative. Set it in. And do the same thing just to kind of keep them out of the way a bit. And I'll do the exact same thing with the negative. Make sure they're all inside that port really well. All the little strands of wire. All right, make sure that's tight up pretty good. You know, you want to check on your connections to make sure they're all firmly locked. Use it a little bit more. And be careful you don't strip them. I mean, you don't want to get insane with it. But now the thinking really is I want to have these plugs just available to plug the solar panels into now. And I'm going to brace these down, the same kind of thing. I'll feed them back through. I want to brace these down right along this same area now. And kind of brace them down with some zap straps so everything's just locked in place and it's all really compact to the box. So I'll just grab a zap strap. I already had one more hole that was available. I'll just feed that through. I pre-drilled these holes off camera so I could just have them. Kind of set them to where I want them to be roughly, and simply zap strap those bad boys on. All right, so that's on there good and tight. Just grab my clip, hold on. Just grab my clippers to clean that up a bit. All right, so the basic functionality of this, and like I said, these are all on there good and secure. They're not going anywhere. Everything's locked in. Pretty good. And when it comes to, hopefully the camera's catching that, I'll see if I can angle it up a bit better. See if I can, yeah. So my thinking really is I want to zap strap these Mc4 connectors now. I just want to peg them up so that they're easily available for me to just plug my solar panels in. So I'm going to drill one more hole here and zap strap it to there, and that way everything's kind of set and locked in place. So I'll do that now. Just grab my drill. You say I want them. In fact, I might even be able to just feed that out through there. Yeah, I can. I like that better. I don't even need to drill another hole. I'm simply just gonna take another zap strap, pull those wires up, and lock them in place. Now I've got Mc4 inputs for my solar charge controller. I'll grab my clippers, just clip off all the little bits of plastic that hang off. Now I've got the basic wiring of this system completed. I can, like I say, plug in some solar panels here, plug into the wall. I can run DC out through the fuse box. So I still plan on putting on one or two more elements that I'll add into this video, but I'll stop at this point in time and I'll quickly just plug this in to one of my solar panels to show you the charge being thrown through the charge controller into the batteries. Okay, so now that I've got the solar charge controller all wired up, and like I say, I've got my Mc4 terminals set off to the side, I'm just going to take my connections to the solar panels, which I've just got sitting over in the window, and I'm simply going to plug those in. As soon as I hook them in, it normally takes a second for the Mppt to lock and track on them. So the battery's at 13.3 volts. Make sure my connections are set tight. It's 21 degrees Celsius. I'm taking a charge now from the solar panel. It's coming in at 15.3 volts. And it's giving me a ½ amp. So it's still early in the morning at the location I'm in. So the sun's not fully out, and I've literally got the solar panel just sitting in the window. So I'm not going to be taking a full charge at this point in time. But you can see the basics of pulling solar in. It's fairly straightforward. So I'll switch gears now though, and while it's taking charge from the solar panels, I'll also turn around and take charge off the wall. So let me just switch camera angles and show that. Okay, so I've plugged the unit into the wall power where the battery charger is throwing charge in the batteries. But you can see at the same point in time, I'm not getting the best sun. This can jump all the way up to 20 amps. But right now I'm getting 0.83 amps. And you can see I've just got a solar panel that's sitting in my window, and it's still fairly early in the day here, so I'm not getting ideal sun. But it just shows the capacity that I'm able to pull power off the sun at the same point in time as I'm pulling power off of the wall. So the primary way that I plan on charging this generator is through solar panels. So this is an Mppt charge controller. I'll show you and these tend to be the more expensive ones and the more efficient ones, but I'll show you a cheaper version of the charge controllers that aren't quite as efficient, but they'll do the job when it comes to converting the solar power energy into battery compatible energy. So I'll show that in the next scene, but as you can see, the core of this generator system is up and running now, where I'm able to take direct feed off the solar, off the wall. I'm able to spit it out as AC power, and I've got the DC fuse box, which I'm going to add in a couple more components so I can kind of make the DC more powerful. But this system is almost entirely complete at this point in time. There's just a few more components that I'm going to show. Okay, so like I say, one of the other things I wanted to show in this video, so this was an Mppt solar charge controller. Like I say, they're a little more pricey, but they're more efficient at the conversion of the power. They'll convert almost all of the power to go straight into the battery. This here is a Pwm Charge Controller. Now these are normally substantially cheaper, but it's the same kind of concept. You have the solar panels in and the battery out to the battery. Now I could have used this unit and bolted it to the inside of this box to keep everything on the inside, but I actually have this unit for a separate project that I'm working on. I've got a few different projects that I'll be doing on my YouTube channel coming in the near future here, but I just wanted to kind of show this as, you know, this unit here is well over $100. It's probably closer to about $130, $140, whereas this unit here is like a $30 unit. So if you're wanting to do this on a budget, you know, you can look at going with cheaper solar charge controllers for sure. But like I say, I've got this for another project, so I won't be installing it, but I could have easily not stuck this Mppt controller on the outside of the box and just attach this to the inside of the box to keep everything inside the box. And this charge controller handles up to 20 amps as well as the Mppt does, or Mppt solar charge controller does. So, you know, the capacity in which they both can go up to in amps is the same, but this just is about 70 to 80% efficient, whereas this one's closer to 99% efficient. And when it comes to producing as much power as possible inside of this setup, that's my ideal objective, is to really have it where I can pump as much power into this as possible. So as the next part of the scenes, I also have a cigarette lighter, so I can plug in 12 volt DC appliances, and I'll be attaching that into this fuse box, and then I'll be mounting it on the outside to the side of the box. So I've got solar devices that use cigarette lighters, and then I also have USB devices, so I'll be mounting both of those into this setup. And then I'll pretty well have this wrapped up. I'll take it outside and plug in a larger solar panel that I have and show you that this Mppt charge controller, in the video earlier it was showing it was only producing, I think it was something like half an amp, you know, or 0.7 of an amp or that kind of thing. But this can easily handle up to 20 amps, but the sun that was coming in through my window was just enough to trigger the solar panels to really kick in more than it was to produce large amounts of power. They're definitely not in an ideal position, but I wanted to show inside, I wanted to show that it has the capacity to pull off the sun at the same time as it has the ability to pull off of the wall. So in the next scene, I'll mount this little cigarette lighter into the fuse box, and then I'll do the USB chargers into there as well. There we go. Yeah, my DC's on there pretty solid now. Just clip them to clean it up a bit. These wires, like I say, I got the positive and the negative. I've got spade terminal connectors, so I'm just going to do the same as I did with the ring terminals where I attached before. Just going to set it in, make sure I get a little bit hanging out the end. And where's my crimping tool? Like I say, make sure I use the yellow one because everything I'm working in is size 10. Squeeze that on pretty good. And as always, when it comes to these things, I kind of like to double do them to make sure they're on tight. The last thing you want is these terminals coming loose. It's always just makes for a less secure situation. Whereas I want everything to be tight, firm, locked. I know it's not going anywhere. Okay, that's good. I'll do the same now with the negative. Put my terminal on. Really crimp it hard. Set the plastic nice and flat. And like I say, give that one extra squeeze to make sure that that's on there. Okay, so now I've got my two terminals, and just like I did with all the other connections, if anything, I want to turn around and potentially brace this so there is no extra tension on this wire that's running through. So I'm going to do that now. I'll just grab my drill. Put a couple holes. Another one of the trusty zap straps. Feed that through. Make sure we're around both wires. Back out. And connect. There. Just helps secure that wire. Because I've got external wires outside on the outside of the box, I really want to make sure that they're just strapped into place so they're not going anywhere. So that just helps me feel a little more secure about what I'm doing. So now the next step, I think these are 20 amps. Let me just check. Yeah, so this is a 20 amp fuse. So as I did previously, I'm going to pop the fuse out so I don't have a live circuit until the last minute. Take my screwdriver and loosen that up. And do the same on the negative. Loosen that up a bit. I'll connect my positive up first. Just want to make sure I get it in underneath the washer that's in there so it gets a really good solid contact. Screw that down so I know that it's not going anywhere. And I'll do the same now with the negative. I don't think I'm under the washer. Hold on. I want to make sure I'm under that washer so I get really good connection to the terminals. There we go. Simply just tighten the negative down to the negative bus bar. check my connections to make sure they're nice and firm. Everything seems pretty solid. I should now have the ability to plug in 12 volt DC cigarette lighter adapter appliances. And the one thing I don't like is, because of the cabling and stuff sticking out, I'm never shy on using a couple more zap straps to make sure everything's super secure. So just pop a couple holes there for that. The last thing I want to have when I'm out in the field and I'm nowhere near any type of electronic devices or anything that I can fix stuff with is to have any of these things have any issue. So, you know, it's better to kind of overbuild at this point in my perspective. That's good. That locks that really solid now. Makes it that I'm not worried about opening up the door with you know, and having it pull off of the box or anything. It seems good in that regard. All right, so I'll clip that. And now I've got cigarette lighter adaptability. So I'll shift camera angles. Well, here, I'll just rotate the box and show you. Hopefully the camera is able to pick this up. I now have the ability to plug in cigarette lighter adapters here. And I've got a solar cooker that's a 12 volt unit and a few other 12 volt units that I can plug into this. So I'll potentially show that in this video, but maybe I'll save that for future videos where I'm hybriding in. I'll just grab my solar cooker. Hold on. So this is a solar cooker, uses the power of sun to cook food, but I can plug this straight into here, turn it on. Oh, I don't have my fuse. So this was a 15 amp circuit that I've got running. So I'm using a 20 amp fuse. I'll plug my fuse in and I'm running power straight off to my solar cooker. This gives me the capacity where even if the sun wasn't out, I can still cook food using this unit. Like I say, I'll show that in far greater detail in future videos of hybriding my solar cooking technology with my electrical technology. But this is kind of a sneak peek at future videos in that regard. So the last thing I want to add on to here is USB capacity. And that way I have the ability to charge up a USB device when I'm out in the field. It already has one on this unit right on the inverter itself, but I don't mind having another couple attached. I've got a spare little 12 volt USB converter wiring. So I'll hook that in next and you guys can see that in. And then I'll take this thing out in the yard and we'll plug it into a larger solar panel and we'll see how much amperage we're getting in off this Mppt controller thrown into the batteries. Okay, so the last component that I want to hook on now is just some USB adapters where it plugs into the 12 volt. I'm just looking for an elegant way to kind of hook this in here because the length of wire they supply to feed off to my leads is pretty restrictive. So I'm just trying to work out exactly where I'm going to set that. I think I might be able to pop it in there, but I just want to make sure I can reach my fuses and stuff. No, and I can't really. So what I'm going to end up doing with this unit is just wiring it in and not bracing this box down, unfortunately. But I just want this unit to be fully up and running at this point in time. So when it comes to the amount of amps that this one needs, this is only pulling 5 volts at 3 amps max. So at 12 volts I can go with a minimal fuse, really. So I think I've got, what are these, 5s I think? No, that's a 10. Hold on. Maybe this one. Yeah, I've got a 5 amp fuse here. So that'll be the one that I want to use for this. It's a little high to what things are, but I just don't have fuses that go low enough. So, you know, to put something on the line for safety's sake is always, you know, a given. But I'll connect it to this terminal on the negative bus bar, and I'll connect it to the next one over on the, in fact, yeah, I'll just connect it on this side. That's fine. I got a lot of stuff going on over there with higher amperage, so I'll just move it over to this side to kind of separate things out a bit. And because I'm going to end up going into that slot, I'll just switch that and move it over there for future use. And I'll leave the fuse out at this point in time. And I'm just going to do exactly the same thing over and over again that we've done previously, where I want the positive feeding in. Let's see if I can get it underneath that washer. I made the mistake of clipping my nails right before I did this video, so I should have really kept them just to have it where I can do little things like this with these. Let's see if I can fish that up a bit. I know I could unscrew the whole thing and da-da-da, but try not to do that. There we go. Just to get in under the washer, right? Now this terminal connection, the spade terminal connection that I use, is really a little bit of a higher gauge than I needed for this wire, but I had a whole set of 10 gauge spade terminals, so I'll just use those. You could switch down to a smaller one, but given this whole structure, I'm okay with it. All right, so the USB is now on there pretty secure. Like I say, the mounting is unfortunate, but what I'm going to do is, where are we going to throw these out? Maybe I'll just spit them out this side. Nah, I don't like that either. I'm just not liking how this is sitting across the terminals and everything else. Don't really want to have that be. So maybe I'll see if I can feed them out here maybe. Yeah, I don't know. Yeah, maybe I'll just position them over to here and feed them out through there. So I have all my kind of connector points all on the side. Yeah, that'll work. I'm pretty easygoing when it comes to that stuff. So I'll just zap strap this into place, and then I'll show you the charging up a device off the USB. Yeah. Okay, so I've wired in my USB, outputs, if you will, and put the cap back on the fuse box, that kind of thing. And I'll show you that this fully functions. So plug it in. You heard the bang. Lets me know I'm charging. So I can charge up to 2 devices at a time. Both of them are working fine. And like I say, they're just hanging out the end, so I can plug whatever into those now. And so now I can run cigarette lighter adapters, USB. I can run additional 12 volt appliances because I haven't consumed all of the fuses sitting in the fuse box at this point in time. This fuse box is rated for 100 amps. So I just have to be mindful of, I don't want to push beyond about 1200 watts going out of the DC, or have it, coming in and going out at the same time, that kind of thing. So, but either way, I'm pretty well done with the build now. I'll kind of do an overhead pan so you guys can see what that looks like. Here, I'll just pop the camera off. I'm just using a bushcraft style tripod that I would normally use when I'm doing bushcraft videos. I kind of improv'd one in my living room because it didn't have a tripod. But as you can see, I just put the cap back on now. Gives it a bit of weatherproofing and stuff, but it's not critical, but pretties it up a bit. But there you have it. So we have the ability to pull off the wall, to produce AC power. We have the ability to plug in. You can see I've only used up 4 out of the possible 12 connections here, but I've got the solar charge controller, so I can do input from the solar. I can do output to the cigarette lighter adapter, and I brace that down with zap straps, so that's on there pretty solid. And then I've got the USB where I can plug in 2 USBs. And like I say, this battery is 2.5 kilowatts worth of power storage. And I can use this for years and years and years to come. You know, as I go, I could have bought a pre-built system. They do sell kind of all-in-one generators on the market. There's things like Jackeries and those types of things out there. But to me, this blows that out of the water. And, you know, those Jackeries, the batteries in them, if you get 5 years out of them tops, you're lucky. You know, I find that they're not necessarily built with ideal circuitry when it comes to power in and power out and the amounts that you can do. Whereas this system is very, because everything's modular, you know, if I want to pop out this inverter and replace it with something more powerful, I can. Or the same with the battery charger, the same with the MPPTs. When it comes to, this seems fairly skinny for the solar charge controllers because I've only hooked on this one that puts in at 20 amps. But I have, I'll just skim over and show you here. I have these solar Suitcase from Renogy. I've got 2 of these and they're 200 watts a piece. They have built-in Pwm Charge Controllers on them. And I've got gator clips on those that I can hook directly onto the battery terminals. So there was a reason why I kept it where I only had 2 connectors onto each terminal. And that was because later on, when I pull out my portable solar Suitcase solar panels that I have, I can connect one 200 watt one with gator clips onto those terminals, and I can hook another one onto these terminals, and then I can use this Mc4 connector to hook onto, I've got a Renogy flexible solar panel there that has 175 watts. I'll pull that out and bring it out in the front where I can get some sun onto this, and you can see this Mppt charge controller working better. But I've got that flexible solar panel where I can use all of those in combination together, feeding into this battery, where all together they produce 575 watts of power at peak. Now, so to give you an idea, to charge this entire 2.5 kilowatt setup, with 5.5 hours of full sun, I can charge it from dead to full. When it comes to, if I had it out in full sun with all the panels and I wanted to plug it into the wall at the same time, I can get the additional 250 watts in on here. You know, it's 14.4 volts at 20 amps, but altogether, when I worked out the math before, it was 831 watts per hour that I can push into this battery stack. You know, and the batteries can take it. Because they're joined in parallel, they can take the amperage, no problems. So when I use both the solar and AC grid power to power this up, I can have this go from dead to full in about 3 hours. To give you an idea, like I say, the solar panels are the main thing that'll be powering this, but because I have the ability to use them all in combination with each other, I can do some significantly fast charging of this. And for my power consumption needs, I could end up using this for 2, 3, 4 days. And that's using the solar cooker to cook food and running lights and those types of things before this unit is going to run out of power. This is really designed with a 3-day redundancy into it, or sorry, latency. I don't know what the exact word would be for that, where I can charge fully from dead to full in a day. And if the weather turned bad and I wasn't getting any type of energy input from anywhere, I could still run this with my load expectancies up to 3 days in a row before I'd have to start to power it up again. And so yeah, there you have it. This unit all together, this case is designed to handle about 70 pounds of weight, and the batteries are 26 pounds a piece, so that brings it up to 52 pounds. And then I've got another maybe 10-15 pounds of electronics, so for under 70 pounds, you can have this level of capacity. And like I say, because it's got the handles on it where it's a crate still, I can just pick this up and throw it in the back of the truck and take it with me and go. You know, it's really a fantastic setup in that regard. But I do plan on doing further videos where I'm using this out in the field and showing the full combination of all the solar panels and that kind of stuff. So that'll be coming in future videos. And I've got a few other videos that I want to put out where I'm using solar that doesn't directly tie to this, but still produces what I call battery-less power systems, where, yeah, you have to have direct full sun to use them, but they produce a significant amount of power that's usable for when you're out in the field. So I'll cut scenes here and just take this outside with that flexible solar panel that I mentioned a few minutes ago in the video. It's definitely not ideal conditions. There's fairly heavy cloud in that, but I just wanted to show that, yes, this does have a far higher capacity. Now, of course, I had to pick a crappy day, you know, when it comes to wielding this out. But like I said, I could still plug into the wall just the same as I was taking charge from multiple charge controllers all at the same time. So that'll be part of my showing in the next videos, where I'll have this flexible solar panel set up. Hopefully I'll get out on a nicer day, but I'll have this flexible solar panel set up pretty well exactly as I have now, where I'm just using the stand as a way to kind of lift and angle the panels to get them on a more ideal angle. And then I'll bring along my Suitcase solar panels, unfold those and hook those on to the battery terminals as described earlier in the video, and see if I can push this up to the 575 watts intake that I'm targeting. But as it goes for right now, other than the fact that it's not very sunny, so I'm not pulling the amps, as it goes right now, I'm pleased with how everything's come together. As a side note, I did add back on that monitor, and on the monitor it shows 4 amps going in, and you can see here 4.0702, so they're very close when it comes to their ratings. There's quite often a little bit of a variance because the batteries have a bit of resistance to taking in the charge, but fairly accurate all around. So, but there you have it, of the electric generator system fully built and ready to use for out in the field. Well, there you have it, guys. If you made it this far in the video, thanks for watching. I hope you enjoyed. Like I say, this unit produces enough power where potentially I can run lights and cook food and that kind of stuff. It's not quite to the degree where you'd be able to heat an area, but you know, I can to a limited degree. But solar really isn't, you know, electric really isn't ideal for running heating stuff. But either way, as we move forward, I'm debating on whether I'm going to start doing some solar heating stuff in future videos, so you might see that. But like I say, I hope you enjoyed this content, and I should have more content coming in the near future. Thanks for watching. Cheers.